Hi guys, today we are solving the MCQ question of IJSO 2023. Let's start with the physics. We have a box with a weight of 100 newtons at the rest, in a horizontal surface. The coefficient of kinetic friction and the coefficient of the static friction between the box and the surface are 0.4 and 0.5 respectively. If the force equal to 42 newtons is applied on the box as shown in the figure, what is the magnitude and direction of the friction force acting on the force? We know the law of the Newton. If we have any object which have mass, and if it stays at the rest, the sum of the force which applies to the box is equal to 0. So we can see that our box is also staying at the rest. Then the force which applies by the left side has the magnitude of 42 newtons, and we have the friction force by this side, by the opposite direction to the dead force, and by using this law we can find out the magnitude of the force. Then like 0 equal to 42 plus friction force. Then we figure it out the friction force that equal to 42 newtons also, and directed by left side, the opposite this force. Then our answer is B. Okay, the second question. Which object has the greatest magnitude of acceleration? Assume that all objects move with a constant acceleration in a straight line. Okay, the first option, A, the vehicle accelerates from 100 kilometers per hour within 4 seconds. Okay, the formula of the acceleration, A equal to delta V, velocity, divided by delta t time, and its unit is meter per second square. Okay, the A option, from the 0 was reached to 100 kilometers per hour. We should convert these kilometers per hour to meter per second to make it more comfortable. We should just divide by 3.6. Okay, by dividing 100 we will get probably 27.7, and it's like, yeah, that's it, meter per second. It's our first option. The second one, B. The rock dart in the free fall near the surface area. We know that G, the acceleration which attract us to the ground, is the constant, and it has the magnitude of 9.81 meter per second square, approximately. Then third option, the C, has the initial speed of 60 kilometers per hour to the rest in 3.2. Okay, also we should convert to the meter per second. 60 divided by 3.6, it will be probably 16.6 meter per second, and we should divide it by 3.2, and we will get a 5.2 meter per second square. That's our third acceleration. Then the last one, the vehicle striding from the rest takes 6.5 to cover the distance of 250 meters. Okay, we know the formula of the acceleration depending from the distance, like x equal to a t squared over 2. This is the x, the distance which covered by this time by constant acceleration. Then distance is equal to 250. Then acceleration is didn't given, and t, we know the time is 6.5 square and divided by 2. By solving this equation, we'll get the a will equal to, so let me use my calculator, 105, that approximately 11.83 meter per second square. Then we should compare all of our results, and we forget divide this by the time. Okay, the first one, 27.7 is dividing by, what was the time? 4. Dividing by 4 is equal to 6.90 second. Okay, comparing the all of the results, we can see that this one has the greatest magnitude. So acceleration, option C has the greatest acceleration. C. Okay, let's start the third question. A bullet of the mass m is shot into the stationary block of the mass m. The block rests on the frictionless floor and is attached at the massless spring with a spring constant k. The bullet embeds itself in the block upon impact. Subsequently, the mass compresses the spring to maximum displacement of x, as illustrated in the figure. Determine the initial velocity of u of the bullet in the terms of m, big M, k, and the x max. Okay, let's start with the firstly, at the initial we had just a bullet with the velocity u. Then it had some kinetic energy. Then it's collided with a big block and had stick it into this block, and this block gained some kinetic energy. Then it was connected to the spring. Then the kinetic energy converted to elastic and was wasted for the extending the spring. Okay, the first equation will be like this. The energy of this spring, k x squared divided by 2, is equal to the total kinetic energy of this block with a bullet in. So m big, m little, divided by 2, and multiplying by the velocity of this block v. Then we can cancel the 2, so kx squared equal to m plus m little divided by v. And we know that u is not equal to the v because the mass was changed. Like initial mass was like little mass, then it became the m plus m. So to find the v, we just need to write equation of momentum. At the first, bullet had the momentum that will equals to me m mass of the bullet multiplying by its own velocity u. Then it became the m big plus m mass of the bullet multiplying by the v, and both of them equal to each other. So m multiplying by u was equal to m big, m little multiplying by v, and we can figure out from this equation the v. Then v will equal to m little multiplying by u dividing by the sum of the both of mass. Then we see that we have the v there, and we can just take it and put instead of this v. So then we have got a new equation, kx squared is equal to m plus m. Then instead of v, we're writing the m equal to u dividing by sum of two mass. And we should remember that we have this square, then it's also multiplying, then we can cancel by 1, then k square, the m square, u square, m plus little m. Then the thing we are looking for is this one, u. So we should take off the from this equation. We can send this part to that side by the multiplying by the two sides. Then we get a new equation, m big plus m kx squared dividing by m squared will equal to u squared. Then we're getting root by the two sides, then cancelling by the power of 2, and x and m getting out of the root, then x dividing by m multiplying by the root, and root we have the m plus m little dividing by m we have a k there. That's it. Okay, let's ask the first question. When they place it in a liquid of the density rho A as first sinks and display the volume of VA of the liquid as shown in the figure. When they place in a liquid of the density rho B, the same sphere floated with a half of its volume appears on the surface of the liquid. When they place it in the liquid of density rho C, the same sphere floats. Determine the magnitude of the buoyant force extended by the liquid of the density rho C on the sphere. Okay, in this, the first situation, we see that displaced volume is equal to VA and our sphere is sinking fully. Then we can make a conclusion that the volume of this sphere is equal to VA, this one. And in the second situation, it sinks only a half of its volume. Then we know that buoyant force is equal to rho, the density of the liquid P, multiplying by the V. The volume has sunk and like 8.5 and equal to J. Then we have the another force by this side was equal to mg, and by an force directed to the upward, the F, and mg. Okay, how we could write the m? We could write the m as density of the object multiplying by the v. Then cos mg is equal to by n force, it stays at the rest. So rho v plus va divided by 2 multiplying by g equal to rho object v and g. va, they're same, we can cancel it, them, and g also. Then rho b is equal to 2 times of density of the object. Okay, it's our the first meaning equation. We should find the force which support to the toward. Okay, then Bionic force will equal to rho c, the density of the liquid, and the third photo, and multiplying by the v of the object which was sinking, and the g. V of the object was sinking, we can write as the fraction of the two densities. The first rho object divided by the rho the liquid in third. Okay, see, but the object's density we should write in terms of the B, because this element it's not given, so that will equal to the B rho divided by rho C and 2, and we can put this equation to this instead of the V0. Then the first will equal to rho S, rho B divided by 2 rho C, and they will cancel, and G, then it will be 1 divided by 2 multiplying by rho B and J. Okay, which is the C option? Answer is C. In the fifth question, two identical leads are connected as shown in the circuit diagram. Each lead needs a current of 10 milliamperes and the potential difference of 1.2 volts. Operate correctly. Calculate the resistance of the resistor R for this circuit to operate under the conditions given above. Okay, we know that the I ampere in this circuit, like current, is constant because just one wire connecting to each other. Then we know that each lead requires the 1.2 volts. For the sum, they need 2.4 volt. Then we know that every element which was connected by the series requires the directed amount of the voltage. Then at the initial there was the potential which is equal to 9, then it take off the 1.2, this also was taken, and this sum of the amount, and here is gonna be 0. So that's why the potential difference between this point and this one is equal to the 9. So we write the equation 9 equal to 1.2 multiplying by 2 by plus the V of the resistor required. Then we find out that VR is equal to, let me use 6.6 volt. Then we should find the resistance by the rule of the ohm. We know that Y is equal to I by R. We put instead of the V 6.6 equal to I, we know it, 10 milli divided by 10 minus 3. Then multiplying with the R, then we get that R is equal to 660 ohms. Then our answer is C option.